Now I have a coding interview question, product except self, that was asked by Uber. You're given a list of numbers or an array, and you have to return an array that contains the product of all elements of the given array except the self. What does that mean? Now let's see. Here we create an array of the same length as the given array, and at the 0 index of this new array we should have 2 times 3 times 4 except the element at 0 index, and it becomes 24, right? Because 2 times 3 times 4 equals to 24. Now at the index 1 we should have 4 times 3 times 1 equals to 12, right? And at the index 2 we should have 4 times 2 times 1. 4 times 2 times 1 equals to 8. And now at the index 3 we should have 3 times 2 times 1 equals to 6. For this array we should return this array, right? You might assume that the result array element will fit in 32 bits, so there is no chance of overflowing. Now try solving this problem in big O of n time complexity and also big O of n space complexity. Now you might be tempted to solve this problem by calculating the product of all elements of the given array, right? And product of this given array should be 24, because 4 times 3 times 2 times 1 equals to 24. Then you will create a new array with the same length as given array. At the index 0 we can divide this number, the product of all items, by the number what we have at the index 0. In this case it will be 24 divided 1 equals to 24. Then at index 1 we will divide this 24 by the number what we have in index 1, in this case 2. Then 24 divided 2, it will be 12. Now at index 2 we'll divide the 24 number by 3, it will be 8, right? And at index 3 we'll divide the number 24 by 4, then it will be 6. Now this is your result array, right? But in this problem you can't use division operator to solve this problem. Then how can solve this problem? Try solving this problem in big O of n time complexity and also big O of n space complexity without using the division operator. When you're done, come back to the solution video. Here's my solutions to this problem, product except self. We have this array for test case. First, I'm going to create a function product except self that takes that array. Then I'm going to find the length of that array, and for this array we have the length is 4, right? Then answer equals to new array with the same length as the given array, right? And here we create an empty array of size 4. Okay, then I'm going to initialize the first index of this new array with 1, because we want to have here the product of all left element of this index 0. In this case we have no element in the left, right? For that we initialize the first index with 1. Then we're going to run a loop for I from index 1 to len minus 1, and we're going to start from here to the end of this array. Then answer I equals to answer I, in this case it points to this element here, right? And answer I equals to num I minus 1. Here I equals to 1. For this iteration 1 minus 1 is 0, and num's 0 and it became this one, right? And then answer I minus 1 and it means this one. Then 1 times 1 equals to 1. And in the next iteration answer I, it points to this element of this new array, then nums I minus 1. Okay, in this case we have the index equals to 2, 2 minus 1, so it points to 2. Then nums I minus 1 equals to 2, and answer I minus 1 equals to 1. Then 2 times 1 equals to 2. Then in the next iteration, answer I, it points to this item here, and in this case we have index 3. Then nums I minus 3. So num 3 minus 1 equals to 2. So 0, 1, 2, 3. Right? 3 times answer I minus 1 is 2. Then 2 times 3 equals to 6. Now we're done with this for loop. Okay? Then we're going to define a variable right equals to 1. Then we're going to run a loop for I from len minus 1 to 0. Then we're going to run a loop from right to left. And here there is no right element of this 6 element, right? For that we use here right equals to 1. Then answer I equals to answer I times right. And in this case, answer I, it points to this index here. In this case 0, 1, 2, 3. This 3 index. Then answer 3 6 times right. Right equals to 1. So 1 times 6 equals to 6. So what we have here? We just overwrite 6 by 6. Then this goes to this line. Right equals to right times nums I. Okay? So right equals to, in this case, 1, and nums I equals to 4, because I equals to 3. Then right equals to 4. Then in these iterations, answer I equals to, and in this case, answer I points to this 2. Then answer I, that means 2 times we have right equals to 4. Then it equals to 2 times 4 equals to 8. And then we overwrite this 2 by 8. Then right equals to right times nums I. We have right equals to 4. 4 times nums I, and nums I equals to 3. Then right equals to, in this case, 3 times 4 equals to 12, right? Then in the next iterations, it points to this element here, okay? In this case, answer I, it equals to this 1, and right equals to 12. So 12 times 1 equals to 12. So here we overwrite this 1 by 12. Then right equals to right times nums I. Right equals to 12 and nums I. In this case, nums I points to this 2, right? And 2 times 12 equals to 24, right? Then we overwrite this 1 by 24, and then right equals to right times nums I, and we update it by 24, because 1 times 24 is 24. And we're done with this loop. We reached at this 0 index. Okay, now at the end we need to return the answer array, right? And this is the return array. Okay, and this is my solutions to this problem, and it takes bigger of n time complexity, and here n is the length of the given array, and it also takes space complexity bigger of n, where n is the length of the given array. Alright, feel free to check out the solution code I attached to this video. Thanks for watching this video, and I'll see you in the next one.